Dear students, now today we are going to discuss a very important probability distribution, that is binomial distribution. So let us look at what is the binomial distribution. A binomial distribution can be thought of as simply the probability of a success or failure outcome in an experiment or survey that is repeated multiple times. The binomial is a type of distribution that has two possible outcomes. The prefix bi means two, TWO, or twice. Okay, the binomial distribution binomial, yani दो पद, two terms. Okay, it is already in school level we know ki how to write x plus a power n or 1 plus x power n. So binomial expression we know very well. So this is very similar to, and the term is the same, binomial expansion, and you know the binomials very well. For example, a coin toss has only two possible outcomes, heads or tails, and taking a test could have two possible outcomes, pass or fail. अगर आप कोई टेस्ट देते हैं तो या तो पास होंगे या फेल होंगे. Binomial distribution must also meet the following three criteria. Okay, the number of observation or trial is fixed. In other words, you can only figure out the probability of something happening if you do it a certain number of times. This is common sense. If you toss a coin once, your probability of getting a tail is 50%. If you toss a coin 20 times, your probability of getting a tails is very close to 100%. Okay. So each observation or trial is independent. In other words, none of your trial have an effect on the probability of the next trial. Okay, so that is the event are independent. The probability of success, tail heads, fail or pass is exactly the same from one trial to another. Let us suppose now we will discuss what is the mathematical computation of binomial distribution, and for this purpose we are going to discuss some certain formula for binomial distribution. Let us suppose the probability of happening of an event once, twice, thrice is smaller times exactly in n trials which are independent is required. Let P be the probability of happening success of an event in a single trial and Q be the probability of not happening, is failure. Then P plus Q is equal to 1. The total probability success and failure is sum of the total property is always 1. It means probability cannot exceed more than 1. The probability of R success and n minus R failure in a specified order is P power R Q into n minus R and Q power n minus R, and the probability of R success in a series of n trial is NCR P power R and Q power n minus R. So you know all the permutation combination. So you already know and familiar with these terms, these coefficients. Now, substituting R is equal to 0, 1, 2, 3 up to R and n in one, probabilities of 0, 1, 2, 3 up to R, n success in a series of an n independent trial may be Q power n NC1P into Q power n minus 1 and so on up to NCR P power R Q power n minus R. So this is the general formula in this case, in case of probability distribution. Now, some more properties, if any examiner is asking any problem related with your previous knowledge, means you know the mean, you know the standard deviation, and then variance. Variance is the square of standard deviation, and this is equal to NPQ. Moment coefficient of skewness, already we have discussed. So what is the moment coefficient of skewness? After knowing this, so Q minus P divided by under root NPQ. So where the symbols are there, usual meaning. Moment coefficient of kurtosis is 3 plus 1 minus 6PQ divided by NPQ. Now let us look one example. Determine the probability of getting 5 heads in 7 tosses of a fair coin. A die is thrown 6 times. Find the probability that 4 will appear exactly 2 times and at least once. Now look the problem. Solution. Probability of getting a head in a single toss is half, that is P. and probability of not getting a head in a single toss is 1 minus 1 by 2 is also half, that is q. Here in the problem n is 7, r is 5, then probability required probability is NC p power r q power n minus r. This is equal to 7c 5 p 5 p power 5 and q power 7 minus 5, that is 2. So if you will simplify, check it, simplify, then you will get 21 by 128. Now, on the case second, probability of getting 4 in a single trial is of course 1 by 6 is equal to p. Okay, only one times and single trial, so 1 by 6. The probability of not getting 4 in a single trial, that is 1 minus 1 by 6, that is 5 by 6. Number of trials are 6, it is already given. Therefore, probability of appearing 4 exactly 2 times means 6 is 2 p power 2 q power 6 minus 2, that is 4, and the value will be 3125 divided by 15552 is equal to about 0.2. Now, probability of appearing 4 at least once is equal to 1 minus probability of appearing 4 0 times, and this is equal to 1 minus this is equal to 0.67. Thank you.